In this session, we will discuss about transmission parameter. Transmission parameter is also called ABCD parameter. Let us see. Transmission or ABCD parameters are widely used in the transmission theory and cascade networks. And you know that in the case of transmission, there will be a sending end and a receiving end. Here, if you are considering a two-port network like this, see this is a two-port network and 1 dash is the input port and 2 dash is the output port. The voltage at the 1 dash is V1, current at the port is I1, voltage at the second port is V2, current at the port is I2, and the directions are also shown in this. And in the case of transmission, we have to recognize one sending end and one receiving end. Here we are assuming that the sending end is 1 dash, receiving end is 2 dash. So sending end variables will be V1 and I1, and that is at the port 1 dash, and receiving end will be output variables will be V2 and I2, and that is at the port 2 dash. And here V1 and I1 are expressed in terms of output variables V2 and I2. So in the case of transmission parameter, we will represent the input variables V1 and I1 in terms of V2 and I2. So V1 and I1 will be the dependent variable and V2 and I2 will be the independent variable. So transmission parameter provides a direct relationship between input and the output. And these parameters are also called circuit parameters or chain parameters. Let us represent the equation for input variables V1 and I1. So V1 will be equal to A into V2 minus B into I2. I1 will be equal to C into V2 minus D into I2. And here we are using a negative sign. That means here V1 is expressed in terms of second port variables V2 and I2. I1 is expressed in terms of second port variables V2 and I2. Okay. And here A, B, C, D are called transmission parameters. And here we are using negative sign. And the sign convention is based on the current leaving the port. Okay. Based on it is not associated with the transmission parameter. Actually, it is associated with the current in the port 2. Okay. So if the current is leaving the port, then the sign convention will be positive. Okay. Here we are assuming that both the port currents are directed towards right. That is, we are assuming that this current is directed towards right. But here it is taken it as directed towards left. That is why we are putting a sign negative. So here ABCD are called transmission parameter or circuit parameter or chain parameter. So you should remember this equation. Okay. From this equation we will be finding out individual transmission parameters. Okay. See, we can represent that equation in terms of matrix form as V1 by V1 I1, matrix V1 I1, and transmission parameters as A, B, Z, D, and other matrix form is V2 and minus I2. That is obtained from this equation. Okay. You can directly matrix V1 I1 is this, and next matrix is A, B, C, D, and next matrix is V2 and I2. That will be a column matrix. Okay, V2 and minus I2. So let us start solving for A, B and C, D. Here, for that, what will happen when the port 2 dash is open? When the port 2 dash is open means there will be no current, that is I2 will be equal to 0. So what will happen to this equation when I2 becomes 0? When I2 becomes 0 means that this term becomes 0. Similarly, this term also becomes 0, right? So from that means whenever we are open circuiting these terminals, the current I2 will be 0. So that we will get the equation for A and C. So we can write A will be equal to V1 by V2. Similarly, C will be equal to I1 by V2, and provided that I2 equal to 0, right? So we can write it as A will be equal to V1 by V2 at I2 equal to 0, and C will be equal to I1 by V2 at I2 equal to 0. From this here, we can write 1 by A equal to V2 by V1. So this will gives the gain, right? That is second port voltage divided by first port voltage, or voltage at the receiving end divided by voltage at the sending end. So that will call so that we can call it as a voltage gain, right? Similarly, we can write here C is this quantity, so 1 by C will be V2 by I1. So this is what is called, this is impedance, and here we are taking the voltage of second port and current of first port. So we can say it as a transfer impedance. Okay. So 1 by C is called the transfer impedance. We can notate it as by using the term Z21. Okay. So 1 by C is called the open circuit transfer impedance, right? Since the second port is open, so we can say it as a open circuit transfer impedance. Next, we have to find out other quantities such as B and D. So to get B and D, what we are doing is we are short circuiting second port. Okay. Here first we are open circuiting the second port. Next we are going to do is this port is short circuiting. So when 2 dash is short circuiting, V2 will become 0. Then what will happen to this equation when V2 equal to 0? So this term will be 0 and this term also will be 0. So we will get the value of B as B will be equal to minus V1 by I2. Similarly, D will be equal to minus I1 by I2. Let us see. So minus B will be equal to V1 by I2 at V2 equal to 0, and minus D equal to I1 by I2 at V2 equal to 0. And here, when we are taking the inverse of this minus B, we will get the equation as I2 by V1. So you can see that this is the ratio of current and voltage. So it will represent admittance. But it represents the current of second port and voltage of first port. So we can use a term transfer admittance. It is obtained by short circuiting the second port. So we can say it as a short circuit transfer admittance. Next, similarly, we have minus D value. When we are taking the inverse of this minus D, we will get a minus 1 by D. That will be equal to I2 by I1. That means it is the ratio of output port current by input port current. So it is representing the current gain, right? So, and it is obtained when V2 equal to 0. That means when we are short circuiting the second port, we are obtaining this quantity. So we can say it as a short circuit current gain. Okay. So now we have different parameters, 1 by A, 1 by B, 1 by C, 1 by D. So these represents different parameters, and inverse of this, that is A, B, C, D, are called transmission parameters. And here you can see that 1 by B represents Y21, that is a short circuit transfer admittance, and this is represented by 1 by D is represented by alpha 21, which represents a short circuit current gain. So next, let us see what will happen to this transmission parameters when we are cascading two different two-port networks. So in that case, we can use transmission matrix for dealing such cascade connection of two-port networks. Okay, let us see what will be the transmission matrix corresponding to this cascaded network. Okay, so here we are having two networks, NX and NY. NX as input port 1, output port 2, X, and NY has input port 1Y and output port 2Y. Okay. And here we are representing the transmission parameters for this NX is AX, CX, BX, DX. Similarly, for the network NY, we are representing the transmission parameters as AY, BY, CY, and DY. See, this is first two-port network, and this is second two-port network. We can either notate it as X or Y or NX or NY, whatever it is. So we are marking the voltages as V1 and I1 here. That is the first port voltage and current. This is the output port for the first network, that is for X. So we are representing it as a V2X and I2X. This is port 22-, and the input for this second network is V1Y and current is I1Y, and the output for this network is V2Y and I2Y. So next we have to find out what will happen to the transmission matrix for this complete connection or complete cascade connection. So we can represent it for the first network X. We can represent it matrix form of this two-port network in the case of in terms of transmission matrix as V1, V1, I1 is the, see here we will be representing V1 and I1 in terms of I2x and V2x. So we can represent it in the transmission matrix form as V1, I1. That will be equal to AX, BX, CX, DX. That is written here. Okay, matrix AX, BX, CX, DX. The output is V2x and minus I2x. So next matrix is V2x and minus I2x. Similarly, we can represent the next network Y in the matrix transmission matrix form as, here the input is V1Y and I1Y. So first matrix is V1Y and I1Y. Second matrix, that will be equal to AY, BY, CY, DY matrix, that is shown here. And next is output. Output is V2Y and I2Y, and associated with I2Y there will be a negative sign. So that will be matrix V2Y and minus I2Y. So these are the two representations for the individual networks, right? So now we are cascading this. So you can see here that when you are cascading, you can see here that this V2x is equal to V1y and I2x is equal to I1y, but its sign is different. Okay. So in this case, at the port 22 dash, we can represent V2x is equal to V1y and I2x is equal to minus I1y. So we can combining these results. So here we have V1 by I1 equal to this matrix. So instead of this one, we can write X, Bx, Cx, Dx. Here V1, I1 equal to X, Bx, Cx, Dx. And instead of V2x and I2x, you can write V2x is equal to V1y. From this portion, you can understand that V2x is equal to V1y and I2x is equal to minus I1y. So instead of this quantity, you can write this matrix. Okay. What is this matrix? V1y, I1y matrix, which is equal to this right side term. So instead of this, you can substitute this entire matrix in the right side. Okay. So you are writing it as AY, BY, CY, DY, V2 minus I2. Here we are not using X terms because we are generalizing it as a V2 and I2. Okay. So this is another matrix which will be a 4 by 4 matrix. When we are multiplying this, we will be getting another 2 by 2 matrix. So let the entries of that matrix be A, B, C, D, which is another values. So you can see that once we are cascading two matrices having two different transmission matrices, we will be getting another transmission matrix. Okay. So that transmission matrix entries will be the product of the individual transmission matrix. Okay. See here ABCD represents ABCD is the product of these two matrices. So here ABCD is called the transmission parameter matrix for the overall network. Thus the transmission matrix of a cascade of two-port network is the product of the transmission matrix of individual networks. That's the thing, okay, that you should remember when you are cascading two networks. The transmission matrix, overall transmission matrix will be the product of individual transmission matrix. Now let us do a problem. Find the transmission or general circuit parameters for the circuit shown in the figure. We can see here that it is a two-port network. Input is A dash, output is B dash. Voltage is V1, output voltage is V2. Input current is I1, output current is I2. Resistors are 1 ohm, 5 ohm and 2 ohm. So first of all, we have to write the equations for input voltage and input current in the case of transmission parameters, that is V1 equal to some equation and V2 equal to, I1 equal to some equation. So V1 will be equal to A into V2 minus B into I1. Okay, that is, so we can write that first equation, that is V1 equal to A into V2 minus B into I2. Similarly, I1 will be equal to C into V2 minus D into I2. So this is the general equation in the case of transmission matrix analysis, transmission parameter. So here we have to find out the value of A, B, C and D. For that, first we are taking the condition that BB dash is open circuiting. That means I2 will become 0. Here this is BB dash. When we are open circuiting these terminals, I2 will become 0. So I2 will become 0. So what will happen to this equation? A will be equal to V1 by V2 and C will be equal to I1 by V2, right? That is written here. A will be equal to V1 by V2 and C will be equal to I1 by V2. And here we want to find out A value, and here either we have to find out V1 or we have to find out V2, and we have to cancel the common terms. Okay. So let us see. Let us go to the diagram. See, you can see here that now this terminals is open, that means I2 equal to 0. I2 0 means that there is no current through this 2 ohm branch. So its meaning is that this portion of the circuit was not there when BB dash is open circuiting. So rest of the portion of the circuit is this one, right? So V1 is the voltage across. What is the value of this V2? See, here we need V2 value, right? So what is the value of V2? V2 is the voltage across BB dash. Since there is no current through this, there is no meaning in that resistance 2 ohm. So V2 will be equal to the voltage across 5 ohm, right? Similarly, V1 will be equal to the voltage across this 1 ohm plus a 5 ohm, right? So the voltage across 5 ohm equal to voltage across voltage V2. So V2 can be written as 5 into I1, right? Since I2 is equal to 0, I1 is the only current which is flowing through this 5 ohm. So 5 I1 will be the V2 value. So you can write V2 equal to 5 I1. Similarly, you know that here V1 is input voltage and that voltage is the voltage across 1 ohm plus voltage across 5 ohm. That is the application of simple Kirchhoff's voltage law. So 6 I1 will be the voltage across these terminals. Okay, A dash equal to 6 V1. Okay, 6 I1. So V1 equal to 6 I1. So you can substitute V1 and V2 in this case. So you will get I1 and I1 get cancelled. So you will get the value 6 by 5 as A. Next you want to find out C. You have the equation C equal to I1 by V2. And here you know that what is I1. You can see here that I1 can be expressed as, this is I1, right? This is I1. That is the current, and I1 will be equal to, what is the value of I1? I1 will be equal to V1 by 6, right? You will get that from this equation. That is equal to I1 equal to V1 by 6 from this equation. Similarly, what is V2? V2 is equal to 5 I1. Either you can proceed in this manner or see here, C equal to I1 by V2. Here V2 will have an equation 5 I1. You can simply substitute this V2 value here, that is equal to V2 equal to 5 I1 here. So I1 by 5 I1 will give you 1 by 5. So C will be that value, okay. Next you want to find out this B and D quantities. For that, now you are open circuiting BB dash, now you have to short circuit BB dash. What will happen when you are short circuiting BB dash? When it is short circuiting, V2 will become 0. That is V2 equal to 0. So when V2 equal to 0, B will be equal to minus V1 by I2 at V2 equal to 0. So when V2 equal to 0 means that this terms will become 0, this also becomes 0. So I2 will be equal to V1 by B equal to V1 by I2 and D equal to I1 by I2. That is the equation here. There is a minus sign, so B will be equal to minus V1 by I2 and D will be equal to minus I1 by I2. So here, first of all, you want to find out B and then you can go to D. So B has the equation minus V1 by I2 and D has the equation minus I1 by I2. So this is your circuit when after short circuiting the BB dash terminals. Here V1 is given, V2 equal to 0. You want to find out this B value first. For that, you want to find out V1 and you have to find out I2. And you have to find an equation for this and you can cancel common terms and you will get the final value for B. For that, let us see. Either you can find V1. Here you can see what is V1. V1 is the voltage drop across 1 ohm plus voltage drop across 5 ohm, right? That is the value of V1. Let us see. See, if you are, this was our circuit. I am redrawing that circuit like this, and this is our equation. This is our equation, okay? See, when you are doing this problem in this manner, see, here the currents are here through this 1 ohm, current is I1, and here the current through 2 ohm is minus I2. So that currents are marked here, and for finding the value of V1, you can apply Kirchhoff's voltage law. See, you can either use this method of current flow, you can assume this method of current flow, or you can go in this manner. Whatever method you can adopt. and I am assuming a current direction like this, okay? And you can see that there is a plus minus sign, there is a plus minus sign, there is plus minus sign. So V1 you can find, by applying KVL you can find that minus V1 minus 2I2 minus 1I1 will be equal to 0. That means minus V1 minus voltage across 1 ohm minus voltage across 2 ohm equal to 0. That is a KVL equation for this loop. Here we can rearrange it as minus V1 equal to voltage across 1 ohm is V1 ohm plus voltage across 2 ohm is V2 ohm. So we have to find out the voltage across 1 ohm and voltage across 2 ohm, and then again you can substitute it in this equation, okay? So let us see what is voltage across 2 ohm. See here, voltage across 1 ohm is voltage across this point, and voltage across 2 ohm means voltage across 2 ohm. What is voltage across 2 ohm? Voltage across 2 ohm means voltage between this point and this point, right? That is voltage across 5 ohm. Here two resistors are connected in parallel, that is 5 ohm and 2 ohm. To finding the voltage across that 2 ohm, see, this was your circuit, 5 ohm and 2 ohm are connected in parallel. To find the voltage across 2 ohm, you can reduce the circuit in this manner. See, 5 and 2 are parallel, those total resistance will be 10 by 7 ohm. So this point will be similar to this point, right? Between these points two resistors were connected. Now we reduce that resistor by the value 10 by 7. So voltage across 2 ohm will be voltage across at this point. So voltage across 2 ohm you can write is equal to voltage across 10 by 7. That will be equal to, what is the voltage value? See, this is a series circuit. What is the voltage across this 10 by 7? Voltage will be equal to current into resistance. So what is the current? I1. Since it is a series part, same current will flow through this part. So voltage across this 10 by 7 ohm will be equal to I1 into 10 by 7. Okay. So that is the equation. We are numbering it as A dash. And also that is this equation is, that is voltage across 2 ohm is represented in terms of I1. Okay. I1 into 10 by 7, that is the value. Also we can write I2 will be equal to, see, here I1 is in this manner and I2 is here. See, we have to use both the circuits parallel. That is why I am drawing this circuit here. And here in this circuit you can see that I1 is flowing in this manner, I2 is also flowing in this manner. And here this is a part and which is connected in series with this combination. So here to find a relationship between I1 and I2, that means we can represent I1 in terms of I2 or I2 in terms of I1. We can apply current divider rule. From the current divider rule, here we can write the current through this 2 ohm will be equal to, that is I2, and that will be equal to total current into resistance 5 divided by total resistance. That is what current divider rule. So we can write a current I2 will be equal to I1 into 5 divided by 5 plus 2, that is 7. So I2 can be written as 5 I1 by 7. So now we have a relation that is connecting I2 and I1. So that is also useful for you to solve this. Okay. See, now you have your equation is this one. Here you want to find out V1 and I2. And V1, if you represent the V1 in terms of I2, then you can cancel the I2 terms. So you will get a final value here. Now V1 equation is minus V1 equal to V1 ohm plus V2 ohm. Now we find out V2 ohm value, and next we have to find out V1 ohm value. See, here we have I2 equal to 5 I1 by 7. We can also write it as I2 equal to 5 by 7 I1. Okay, 5 by 7, that is the same equation, that is C dash equation. And also I1, how can you rearrange this equation? I1 equal to 7 I2 by 5. So now we have the equation of voltage across 2 ohm, which is equal to, what is voltage across 2 ohm? Voltage across 2 ohm is equal to I1 into 10 by 7. And we are representing that equation in terms of I2, that is equal to 7. We have a V2 ohm is equal to I1 into 10 by 7. So instead of I1 we are representing, what is I1? 7 I2 by 5. Instead of I1 we are representing 7 I2 by 5 here. And we are cancelling common terms. So we will get 2 I2. V2 ohm is equal to 2 I2. So now you got the equation of voltage across 2 ohm in terms of I2. Next you want to find out minus V1. You have the equation. See here, you are starting from here, minus V1 equal to V1 ohm plus V2 ohm. So that equation we are writing here, minus V1 equal to V1 ohm plus V2 ohm. You know that from the circuit diagram, what is voltage across 1 ohm? See here, this is the circuit. What is voltage across 1 ohm? Voltage across 1 ohm is equal to current into I1 into resistance 1 ohm, right? Okay, so you can write it as a voltage across V1 ohm is equal to I1 into 1 plus V2 ohm that you have obtained in the previous equation, that is V2 ohm is equal to 2I2. So you can write it 1 I1 plus 2 I2. So I1 again you can written in terms of I2, that is in terms of I2 you can represent I1 equal to 7 I2 by 5, that is 7 I2 by 5 we written this value instead of I1. You can solve this equation, so you will get a minus V1 equal to 17 I2 by 5. So B value is minus V1 by I2. So you can substitute this value instead of minus V1, and common terms will be cancelled out, that is I2 is cancelled out, so you will get a 17 by 5. So B value is 17 by 5. Next you have one more term, that is D value. You have the equation for D. See here, D is equal to minus I1 by I2 at V2 equal to 0. So what is I1 and what is I2? Now you have the equation for I1 and I2. See, I1 can be written in terms of I2 as a C. I1 equal to 7 I2 by 5. So you can represent it as instead of I1 7 I2 by 5 you can written, or instead of I2 you can written it as 5 by 7 into I1. So you will get I1 and I1 or I2 by or I2 by I2 will get cancelled. So you will get 7 by 5 is the value for D. There will be a negative sign, that is minus 7 by 5 is D value. So now you got different transmission parameter values A, B, C and D. Okay, this is the way you can go through the problem once again and you will get the concept clearer. These are simple applications of Ohm's law. You should know where you have to apply KCL or KVL, like that, then you will get the solution. Okay. Next, what is inverse transmission parameter? Now we discussed about A, B, C, D parameter. Now we are discussing about inverse transmission parameter, that is A dash, B dash, C dash, D dash. And here this is similar to the transmission parameter, but we are taking the, see here in the previous case we are taking first port, that is 1 dash as sending port and 2 dash as receiving port. Now here we are representing the receiving port voltage and current in terms of sending port voltage and current. So voltage and current at the receiving end can also be expressed in terms of voltage and currents at the sending end. And here we are recognizing, see, this is the diagram. Here 1 dash is the sending end, 2 dash is the receiving end. Voltage at the 2 dash is V2 and I2. I2 is the current, and voltage at the sending end is V1 and current at the sending end is I1. In the case of inverse transmission parameter, we are representing this voltage and current at the receiving end in terms of voltage and current at the transmitting end. That means here V2 and I2 are dependent variables and V1 and I1 are independent variables. So we can write the output voltage as V2, that will be equal to A dash V1 minus B dash I1. And I2 is represented in terms of V1 and I1 as a C dash V1 minus D dash I1. And this equation can be represented in terms of a matrix form, that is V2, I2 will be the first matrix, and that will be equal to second matrix is A dash B dash C dash D dash. Third matrix will be V1 and I1 minus I1. Okay, that will be the matrix. And actually here we are not representing the matrix, you can write it in the matrix form. Okay, and the coefficients A dash, here the coefficients A dash, B dash, C dash and D dash are called inverse transmission parameters. And here also we will get different inverse coefficient parameters, that is A dash, B dash, C dash and D dash by open circuiting or short circuiting the 1 dash port. In the previous case we were short circuiting or open circuiting the 2 dash port, and now here we are short circuiting or open circuiting 1 dash port. Okay, so when 1 dash port is open circuited, see 1 dash port is open circuited means I1 will be equal to 0. So this term will not be there and this also will not be there. So when I1 equal to 0, we will get A dash equal to V2 by V1. Similarly, C dash will be equal to I2 by V1. So we will have A dash equal to V2 by V1 and C dash equal to I2 by V1. That is at I1 equal to 0. For getting the other parameter, we are short circuiting the port 1 1 dash. So when we are short circuiting this port, then V1 will become 0. So what will happen when V1 equal to 0? This term will not be there and this also will not be there. So we will get B dash is equal to minus V2 by I1 and D dash is equal to minus I2 by I1. Okay. So this is the case. So these are the inverse transmission parameters. You can go through the problems and if you have any doubts, you can ask me. Okay, that's all about this topic. Thank you.